Okay, this one is the one where we're doing like rates, proportion things, diagram, ratios. Okay, so on this one, we're going to do a comparison of what's cheaper. So when you do this, you have to be in the same units. So let's decide, what are we going to put everything in? Do you want to make everything into the kilograms or everything into the pounds? And it doesn't matter. We just have to pick something to be pounds. Okay. So this, we don't have to do anything with that right now. Let's grab that. So here's my first thing. I'm going to go 3 kilograms is going to be how many pounds? I'm going to figure that out. And what do I know? It gave me it. 1 kilogram is 2.2 pounds. So this is what I have and I want to get. And this is the note. I know that. Everything in this unit can really be set up with multiply, divide, like cross multiplies, right? Multiply, divide by 1 makes 6.6 pounds. So that was step 1. You had to get one of them changed over. Okay, so here I go. 76.65 for 6.6 pounds. What would that be as a per 1 pound? I need to get I'm going to get the unit price of it. What's that cost per pound? Okay, FYI, this makes sense, price per pound. It does not make sense to do pounds per dollar as a unit price, right? That doesn't really make sense. Okay, so price per pound, right? Good? Do the same thing. $23.50 is the price for 2 pounds.
You did multiply then divide?
Yep.
Okay.
So which 2 is the connection?
1 and this 7.
1 and that
And
divide by.
Yeah.
Sorry, I didn't write 1 pound, but there's 1 pound. Right?
Yeah.
Multiply. Divide. Yeah, everything can basically go in that kind of format, right?
So then it would just be 23.50 divided by 2.
Yep. Okay, and guess what? You have to actually answer the question. Which store is cheaper? This is less money. Okay, 2 racers from different towns want to see who's faster. The first racer reported 5 kilometers in 38 minutes, 3 miles in 0.4 hours. Okay, so this isn't good. We got every mix of units going on. Okay, so the kilometer mile thing, we want to get them both to be the same. So just pick, what do you want to do this whole problem with? Do we want to go everything kilometers or everything miles? Miles, okay. So I'm going to grab 5 kilometers and switch it to miles. So what do I know? Over here, what do you want to use? It doesn't matter. I'm going to go 1 kilometer is 0.62 miles. Okay, so I don't want 5 kilometers. I'm going to change that 5 kilometers and replace it. Okay. The other thing is, I don't I don't like this like minutes, hours, you can't have that mixing. So what do we want to do here? Minutes, okay, so 0.4 hours is how many minutes? Okay, sorry, this is not something I'm going to write for you. I'm going to expect you to know this one. 1 hour is 60 minutes. Okay, so cross off that hour and replace it with a minute value. Okay, we got our things all set up, same units everywhere. So now we have to make a direct comparison, making something the same. So here we did it per 1 pound, per 1 pound. Okay, I'm going to tell you this. As a distance, it honestly doesn't really make sense about doing a distance per minute. Who talks about how much you're going in 1 minute, right? That's a little bit, it's going to be a really small number. Would it be okay if we did a comparison of these using each with a 60-minute, like a 1 hour? Is that okay? Would that make a little bit more sense with numbers? Okay, so now that we have same units, we're also going to make a same comparable number, exact same. Okay, there you go. Times, divide. Did I type that right? Everybody match my numbers?
Yeah.
Yeah. Okay, lots of you did this work very well on your test, but you answered it wrong. Who would be a faster person? Is it faster if you run this much in an hour or this much in an hour? Second one. So do you see how the lower one is actually worse, right? Okay, so that was just tricky because some of you picked the lower one because you were used to being cheaper or whatever. Okay, 3, reading a interval chart. So this plane is descending from flying to dropping. Where is it going the fastest? Which section? AB, BC, or CD? CD. And you know what I can observe? I'm just looking really for the steepest. If some line is moving quickly, that means the interval, the rate is going quickly. Explain what's happening in the interval B to C. What's the plane doing? In the zone B to C, what's the plane doing? Flat airplane. It's level. It's not descending, right? It's just staying flat. Sometimes when we talk about people moving, they might just be stationary or something too. And let's figure out the actual rate from C to D.
You're running second.
It's pressure, Jen.
You're running plane second?
This was me last night, so it's not good news.
Plane second?
Sure.
Do we get to skip class last night?
No, there is no class.
There's no class, just gonna watch.
In the afternoon?
Yeah.
Or is it so,
I-
like 4th and 5th?
2 p.m.
No, it's like just this much of fourth.
15
So
minutes.
just 5.
Like-
And watermelon Wellkuchen. So like can't go wrong,
I don't
right?
know what that is, but yeah.
What? Caleb, so disappointing. You don't know what Wellkuchen
I've
is?
had it once,
Oh.
like a summer class at school, but like, it's
Oh.
like, it's bread.
Yeah, like a dough, fried dough.
Yeah. I'm not mad at it.
Just. Okay.
Yes, okay, I'm not.
From C to D, can you tell me the increment of feet that they've moved?
Mission Churchill, we have Bannock.
Rolkeegan is S tier, Bannock's maybe D tier.
Bro, Bannock done right by the Offies is so good. Bro,
We have like a recipe from the Offies from Churchill. It's so hard.
I promise you it's so good, Marcy's
Ireland, from Churchill.
Okay, in the C to D section, I have moved a total of 2,000 feet. And how much time has gone by in that zone? Can anybody figure out the time that I've done in that zone?
72 minutes.
10 minutes.
This Molly driver. There's been any time.
35 to 45 means you've surpassed 10 minutes of time. So when we talk about rates, it's good to do it as a unit rate. So what feet per 1 minute?
Divide.
So times, divide.
That's a lot.
Yes, like I'm trying to think of what we would want from that though. Okay, I'm gonna flip the page. Flip the page. Okay, is there anything we need to write about proportions out of that? I am not giving you things like how many millimeters in a centimeter. I'm not giving you that, so that is something, if you don't know, I don't write on your cheat sheet. Feet and inches, I do not give you that conversion. Do you need that on your cheat sheet? You put it on there if you feel like you need it. Your ratio is 1 foot is 12 inches.
So feet inches would be times by 4.
How many centimeters are in an inch?
2.54. But I would give you that. That would be something I'm giving.
Okay.
Centimeters to inches, that's a give.
We're just doing our own math right now.
But if you're metric to metric, I'm not doing that for you. How many centimeters are in 1 meter? 100? How many meters are in a kilometer? 1,000, okay? Okay, here we go. Scales is our next topic. Okay, scales. We're going to do just a couple of examples. I'm going to skip some of these, but we're going to do a couple and then we're going to write on our cheat sheet. So, diagram to real is the format of making a scale. Okay, so diagram to real. Two values. Identify which one is showing me a diagram value and which one is showing me a real life value. So that's what you do. You take your two values. Which one is a diagram number? Which one is that one? The diagram is the 2 number, okay, which means this is the real one. Okay, great. We've identified that. What's our situation problem here? What's the problem with these values? Centimeters and millimeters. Okay, they can't do that. So which one are we going to change? Which one's easier to change? Anybody know? Centimeters is easier to go to millimeters. What do you do?
Divide by 100.
10 millimeters in a centimeter.
Okay,
So this would be
Yeah.
times by 10.
What's, oh, I was looking at meters.
Okay, so there we go. We have now changed to millimeters. So you told me that this was the diagram number, and then this is the real life number. Okay, now here's the idea. You need to make whatever one is smaller, turn it into a 1. Which number's the smaller number? 1.95. Turn it into a 1. And then what do you do to get the missing part of a 4-part thing? Multiply, divide. Turn the smaller thing into a 1 and then multiply, divide, and that gets you your diagram. So in this case, my diagram is enlarged of my real life object, right? Because look at a thickness of a coin is very small. So on the paper, you're probably going to want to draw it bigger. Okay, and we'll do one more question like that. And then we're done with that section. So a bedroom is that, and it's drawn with that. So 2 pieces of information, identify what's the diagram, identify what's the real. Okay, so there's my identification, diagram value, real life value. Okay, great. Now, check out the units. Not good. Feet, inches. What's easier to change? Should it work better if I'm going feet to inches or inches to feet? Which one do you think is easier?
Feet inches.
Feet times 12, 150 inches. There we go.
I don't understand how it's relative.
Okay, here we go. Diagram to real is the system of how to write. So, diagram to real is now like that. This is my diagram number, my real number. Turn the smaller value to a 1, which is that. And then
On the exam, all these numbers will be like whole numbers, like numbers.
usually-ish, yeah, I think so. Yeah. It's fine, I'll make it up as I go.
Actually,
Okay, ready? Area scale factor equals linear scale factor squared. And linear scale factor equals the square root of the area, right? Vice versa? Do you remember that? It's proportions. How do you get a volume? How do you see what is happening with the volume of something? Linear scale factor would get cubed. And how do you get a linear scale factor if given volume? Cube root of your volume scale factor.
You have to do this whole page.
No. I'll stop it here.
Is mine the same again? Read it. I just take a picture of that just in case.
Just wait till I'm done then, if you want.
Just like,
Yeah, but I'm gonna write more better stuff. And
just
then,
that.
well, yeah, but why don't you just take it of the whole thing when I'm done? You can. I'll give you the paper. Okay. Sometimes I give you an original measurement and then I ask you what's the measure on the second object. You would times by the scale factor. What if I gave you the ending measure and I wanted you to figure out the original? What would you do different? Divide by the scale factor. Okay? If your scale factor is less than 1, like a small number, like a half, what is that showing me? Your new one would be smaller, right? If there's a scale factor that's less than 1, it means you're ending on an object that is smaller. And if your scale factor is bigger than 1, what are you going to know about your new object? It would get bigger, right? Does that make sense? So we can convert between scale factors using area and volume, and we might need to figure out what the original volumes or original heights or whatever it is. Okay, so a circle had a diameter of 56, and then it was reduced to be 7.
Which 13?
Okay, so it was reduced. So what do I know about my linear scale factor? What do I know about my linear scale factor that represents that this object got reduced?
How do you know it's linear?
Because it's a diameter. Is diameter area or a volume? Nope. Diameter is just a linear measure, right? Widths, lengths, heights, diameters, radius, that's all linear. Okay? Okay. It's reduced. So this has to be what? If I know it's reduced, it has to be less than 1. Okay, so which one do I want to do? Should I do 56 divided by 7 or 7 divided by 56 to make that number small? Which one would be better? If I did this divided by this, I get 8. Does that show a reduction? 8?
No.
No. So I better go this way. 7 divided by 56.
0.125.
Okay, so that would have been one trick to figure that out. Okay, if you had divided the other way, you would have had a scale factor of 8, and that would show me enlarging something.
So if it's enlarging,
It's bigger than 1.
but if it's enlarging, you're dividing the bigger number by smaller.
Yeah. I mean, you have 2 trials, and I'm making sure that number is either bigger or less than 1. Yeah.
Shrinking.
Okay, what's the scale factor for the areas changing? So what is the area scale factor? What do you do? We wrote it on our cheat sheet actually, exactly this. Just jumps in and answers it. Okay. Second question. Okay, I was given the area of this and the area of this. So I can compare two areas with each other. So this would get me an area scale factor if I compare two areas. So did we enlarge or did we reduce? First was 900 and the second one was 10. Does that show me something enlarging or reducing? Reducing. So pick which dividing you want to do to make sure that's less than 1.
Bigger but small. Oh, if it's shrinking, smaller by. Are we shrinking it or enlarging?
Well, this is 900 and then it became 10. So it does shrinking.
So 10 divided by 900.
Yeah.
Okay.
Guess what? Just try each one and look on your calculator and which number is showing me under 1, right? Does that make sense? Because if you had done it the wrong way, it's all good because you would get 90 and you'd say, oh, that's not showing me reduction. That's an enlargement.
But it's less than 900.
No, but it needs to be less than 1 to be a reduction. Here's on your cheat sheet. If your scale factor is under 1, it's making something smaller. Okay?
I wrote that down.
Yeah.
That makes sense.
So this is less than 1, right? This is okay. What scale factor is the change of my sides? So what am I asking you to find? What are the sides changing by? Linear. Linear scale factor. So how do I go from an area stuff to linear stuff? Square root. And guess what? I actually still have it on my calculator, right? Square root that Okay, question 15 and 16. We got 2 to go. 15 and 16. Okay, here we go. A water bottle has a volume of this. So this is my original volume. That's what that is showing me. It's the original volume. For the drawing, you used a scale factor of 0.4 for the dimensions of it. So this is a scale factor for what? Linear, area, or volume? Linear, because it says for the dimensions. It was changing the dimensions, so we're going to label this as a linear scale factor. For the drawing, this scale factor was used to change the area. I don't know, but that wouldn't really, yeah, I don't think I would. Dimensions just mean like lengths and widths and heights. Okay, what is the new volume? That's my question. Okay, so what do you think I really need to find out? If I want to compare to get volumes, what do you think I need? I don't want linear scale factor, I want a volume scale factor. How do you get that volume scale factor? Linear scale factor cubed. So that is how my volume is changing. Okay. now I got everything with volume. I have my original volume. I have my scale factor with my volume. So what is my new volume?
1140.
What am I going to do with these numbers? Should I times that way or should I divide that way?
Subtract.
That wasn't an option. Times or divide. Original to get to the new. Times.
Everyone in for some BP.
Okay, so there was the trick. I wanted to know stuff about volume, so I didn't want the scale factor of sides. I wanted the volume scale factor. So we wrote that down on our cheat sheet, and we wrote how to go from original to a new. Okay, last, and then we're done. Okay, volume of the first cube, volume of the second cube. What is the sides scale factor?
So going from volume square factor to linear square.
Nick wants to take a couple swings, Marcy.
We're gonna have a volume scale factor, and we gotta end up with a linear.
Also, you to.
Yep.
Bro, I want
Okay.
you to take some swings.
Oh my goodness, get out of here. Stop messaging. Okay,
They take it really seriously. Do they?
okay, this is comparing volumes. So if I compare two volumes, okay, I need you for 10 more seconds here, basically. I'm almost done. Comparing two volumes, I'm gonna get me a volume scale factor. Should this show me enlargement or reduction? Enlargement. So divide them, make sure it's bigger than 1. Okay. Divide them. Which way are you going to divide to show me that's an enlargement?
2,000 divided by 700.
Free day.
And that equals volume?
Volume scale factor. That's the change of the volumes with each other, right? And my question says, what is the scale factor of the sides of this thing? So what is that asking me? What's the linear scale factor?
1440.
How do I get there from the volume? How do you go from a volume to, what is volume measured in? Cubes. So then I do the cube root.
I'm gonna guess what this is.
Do we all remember actually how to type that in?
Let me guess. Is it 2.744? I'm gonna guess 1.